Welcome back to The Explainer. Today, we are getting right into it. Network optimization, field verification, and the power of subnetting. Look, we're talking about the absolute invisible architecture that literally keeps modern businesses alive. What actually happens out there in the field when techs are setting up, verifying, or honestly just trying to fix a massive digital infrastructure. The real-world stakes here, they couldn't be higher. I mean, if a network isn't optimized and verified from the ground up, entire corporate systems can just grind to a total halt. It is literally the difference between a lightning-fast, seamless workspace and an absolute nightmare of dropped connections, sluggish speeds, and totally vulnerable data. So today, we're going to break down exactly how the pros tackle this on the ground using some really clear, structured blueprints. Let's get into it.
Okay, let's dive into this. Ever wonder what prevents a local network from just collapsing into total chaos? Think about it. You walk into a massive office building, right? You've got hundreds of laptops, void phones, security cameras, servers, and they're all firing off data at the exact same time. Why doesn't the whole system just instantly buckle under the weight of its own digital noise? What's the invisible traffic cop keeping everyone in line? Well, the answer comes down to a very specific set of rules and physical boundaries that IT professionals lock in before a single device even goes online.
I want you to picture this. You're a brand new tech, right? You just arrived on site for a massive corporate deployment, and your veteran mentor turns to you, looks you dead in the eye, and drops this truth bomb. Every time you step onto a customer site, consistency is your best friend. It's so true. You don't just plug things in, cross your fingers, and hope for the best. You don't guess. You follow a rigorous, totally non-negotiable process. Because out there in the field, when you're dealing with hardware, assumption is your absolute worst enemy. Consistency, that's the only thing that guarantees a reliable connection.
Which brings us to Section 1, the field verification trinity. So, to get that absolute consistency, techs rely on this non-negotiable checklist. You literally have to execute this flawlessly before any real network work even starts. Think of it like looking down at a digital tablet in your hand right now. Step 1, the IP address. You gotta ask, is it in the right private range for the local router? Okay, step 2, the subnet mask. Does it perfectly match the rest of the LAN configuration? You know, usually that classic 255.255.255.0. And finally, step 3, the default gateway. Is it pointing directly to the exact local IP of the router? It sounds super simple, right? But here's the kicker. If you miss even one of these, boom, communication breaks. Your device is basically sitting in a closed room speaking a totally different language.
Moving right along to Section 2, the flat network problem.
Okay, so mastering that trinity gets one device online. But what happens when you're looking at 500 devices? Yeah, things get complicated fast. Look at this brilliant analogy we've got here. Imagine a giant single hall with 500 people trapped inside, and they are all shouting at the exact same time just to get each other's attention. That right there, that's a flat network. Every single device broadcasts to every other device. And fun fact, a severe broadcast storm can literally bring a massive enterprise network to its knees in under 60 seconds. It's just this chaotic storm of traffic that slows the whole system to a crawl. But now, imagine taking that exact same building and installing clean, soundproof glass partitions. You separate HR, finance, IT. Suddenly, smooth, quiet operations. The shouting is completely contained.
And that glass wall solution actually has a name, subnetting. Subnetting is basically the structural organization technique of splitting a huge, chaotic network into smaller, bite-sized, manageable subnetworks. The whole point here is to contain local traffic strictly within its own boundary. It's the architectural magic that throws up those glass walls and keeps that excessive broadcast traffic under control so your system doesn't just crash and burn.
Let's jump to Section 3, strategic benefits of subnetting. So, now that we know what subnetting actually does, let's break down the specific tactical victories you get when you divide a network up properly. We've got 4 main benefits here. First up, traffic control. This blocks those massive broadcast storms from lagging the whole LAN. Second, hardened security. This is crucial. It walls off your sensitive corporate core from, say, the public guest Wi-Fi. Third, rapid triage. If a bug or virus gets in, you isolate the sickness so the entire network doesn't go down. It just traps the issue in one tiny, controlled zone. And fourth, clean management. You're neatly grouping devices by function. So you keep all the IP phones over here in one subnet, security cameras over there, and man, it makes troubleshooting an absolute breeze.
Next up, Section 4, the subnet mask stencil.
All right, so we know we need the glass walls, but how do we actually build these structures? How do techs draw those boundaries using code? Well, they
They use the subnet mask. And I don't want you to think of the subnet mask as some crazy, abstract math equation. Nope. Think of it more like a tactile key lock mechanism. It acts exactly like a stencil that you place right over an IP address to define the precise physical boundary of your local network neighborhood.
Now, this stencil operates on some really strict binary logic. The first part, the rule of 255. Whenever you hear the number 255 in a subnet mask, I want you to instantly think of the word lock, okay? Wherever that 255 sits, it seals the network neighborhood name in stone. It completely locks down that section of the IP address. It's fixed, it's set, you literally cannot change it.
Then you have the second part of the logic, the rule of zero. When you see a zero in the subnet mask, think of the word open. Wherever that zero sits, that space is left completely free and clear. It's the host part of the address. It basically leaves that section open, so you can assign unique individual house numbers to specific laptops or servers or IP phones.
So, let's bring it all together and see how these two rules actually interact. Let's say your device's IP address is 192.168.1.15. We take our default subnet mask stencil, which, you guessed it, is 255.255.255.0, and we literally stamp it directly over that IP address. Those three 255s act as a locked blue block over the 192.168.1. Boom. That is now firmly set as your locked neighborhood. But that 0 at the end, that acts as an open orange circle right over the number 15. That 15 is your unique device ID. It's your very own house number within that locked neighborhood. By using this stencil, your device knows exactly where its neighborhood ends and where the vast outside world begins.
So, there you have it. You've got the stencil. You understand how these boundaries work. You know exactly how to tame a wild flat network and swap out that chaotic shouting room for structured, secure glass walls. Master the checklist, understand the mask, and honestly, you can conquer any digital landscape out there. So, the question is, you have the stencil. How will you organize your next network structure? Keep that in mind, and we will see you on the next explainer.